afternoon. We're in my train room, and I'm going to be talking about a double slip switch. My layout turns out is an ON30, but this is applicable to anything. This is an SL90 double slip switch by Pico. It's an amazingly creative piece of engineering, but it requires a lot of paying attention to. And I did not want to have to do that for I would just be looking at that and nothing else on my layout. So I developed some red-green LEDs on my switchboard that I will show you how I developed and made that electronics function for this double slip switch. And so next I'm going to show you how it functions, and then we'll move on to the switchboard. Okay, here's the double slip switch I was telling you about. It's a pretty amazing piece of engineering. What you can see is that it only has 2 switch motors versus normally a slip switch has 4 switch motors and allows you to transition from one track to the next. And here what I have is I have 2 tracks that cross each other, and I want it to be able to go from one loop to the other. So here's how this double slip switch works. When this is down and this is down, this boxcar will go across this way. When this is down and this is up, it will go across, and when they're both up, this will go in this fashion, and when this is up and this is down, it will go back across. So pretty amazing piece of engineering in general. Now, okay, let's take a much closer look at this slip switch done by Pico. And what you can see is that you can see all of these amazing engineered rails, which I just, it boggles my mind how they figured out how to do all of these plastic pieces and metal pieces and make sure that all the currents work. As you can see, there's 2 switch motors, as I talked about before, and depending on how they're thrown is what allows me to make the train go in one direction or the other. And as you can see, when I want to go in one direction, I flip this one back and forth, and similarly here, throwing it this way or throwing it that way will make sure the train does not derail. Now, it's pretty intensive to have to look at only this to ensure that your train does not derail as it comes along, and to memorize the position of these rails or the up and down positions of these switch motors to ensure that you're going to get it right. So that's a little too intensive for me, and I developed some electronics on a switchboard to manage this the direction of the slip switch. And that's the next thing we're going to take a look at. I'll show you my switchboard, and then we'll go on to take a look at the electronics that are necessary in order to put that together. Okay, I've turned on the lights for my LEDs, and here is the double slip switch. And what you can see is the green means the train is going to go in that direction. When I flip this toggle switch, it means that it's going to go across from each other. When I throw this toggle switch, it's going to go across that way, and when I throw it up, it goes all the way across. All of the switch machines are also tied to these LEDs. So, and you only have 2 switch machines that are being thrown. And it's a question of whether they're both up, both down, one is up, the other one's down, or vice versa. And that gives you the 4 positions that you need in order to be able to make the train go in the directions that you want. So what we're going to do is we're going to take a look at the electronics that are under here and attached to the switches in order to make all of that happen. It's pretty complex, and as I've mentioned before, I'm not that good at electronics, but I have a friend who is, and that's what you want. You want a good friend who's good at electronics, and you just solder and put everything the way it really is, and then if it doesn't work, you go yell at him, and then he looks at it closely and he tells you misconnected something or other, and you fix it, and then it all works out. Okay, So let's take a look at the electronics next. Here is the electronic diagram that that is actually under the control panel. Now, there's a lot of colors, there's a lot of lines and so on. So I'll go through these sort of individually. And it looks complicated, but it really isn't. You just need to take your time to connect these things. So let's go through each one of these colors, and then and no worries, I will eventually we'll go through the parts list as well. So the first thing to notice is this orange and this orange dot. These are connected, right? This is a single wire that goes from the center pole, and this purple dot and that purple dot are actually connected. I didn't want to put the line in because it just made everything look even messier than it already is. What we have over here is a double pole, double throw, momentary toggle switch. And it's important that it be momentary, otherwise you're going to burn your circuits out. The same is true for a second double pole, double throw, toggle momentary switch. And I'll show you a diagram of what each one of these things are. Over here, these things with the arrow line like this are called diodes. They allow the current to only flow in one direction. These are latching relays, and they have poles coming out of them in this configuration of 3, 2, and then 3, 2, like this. And there's 2 of them. And then there are 4 red-white LEDs. These are the 5 millimeter LEDs. I like them because they give me enough light. And they have 3 poles. And they have 1 pole that's going to go to the 12-volt source. And then they have 1 pole that's, if the current goes in this direction, it's red. If the current goes into this direction, it's green. And what you see is basically if you hook this up, you're going to be able to have 4 LEDs that light up differently. All right, these 2 poles on the latching relay go to the 12 volts. And then these middle poles on the double pole, double throw switch goes into the other part of your 12 volt power supply. Every time you see this sign, this means 100 ohm resistor. I didn't have the little symbol, and I tried to create it, but it's just a mess. So every time you see one of these, and there's probably more resistance here than is necessary, but I just don't want to burn out the LEDs because that's a lot of work to sort of unsolder. These are very, very small posts to solder to. So you want, I'm very messy solderer, as you'll see when we go and look at what it really looks like. All right, so from this post, you want 1 wire that goes to the red side of LED 1, and that same post you want to go to the green side of LED 2. These little jaunty thingies means that they're not connected, as you see here. These 2 wires do not connect, right? They just go over each other. Same thing here, and down here, and there. I didn't put them here because it started looking way too messy. That's why I changed the colors. The blue and green diodes they're not any different from one another. By the way, feel free to just take a screenshot or capture the screen to use this as much as you want. And then the second post, it goes in the opposite direction, right? So 1 to the green side of LED 1 and another connection to the red side of LED 2. Very similar situation for LED 3 and 4. As you can see, they're effectively mirror images to 2 other LEDs of one another. So when I'm soldering these, I'm soldering them together. And you'll see what I actually put a strip right here with screws in order to make this a lot easier. Otherwise, there would be solder joints everywhere. Okay, so the diodes go to the other side poles, posts of the dipole, double throw toggle switches. There's two of these diodes that go in. They allow the current to flow in one direction. They go from this direction. They don't allow the current to go in the other directions. This was necessary to make all of this work. All right, so this is what it looks like. Do one at a time, slowly, you will be fine. Just follow this diagram. This side of the double pole, double throw switch is for the switch machines that are on the slip switch itself. That will be a separate video than this because that has its own complexity. So one impossible task at a time. The next thing is you saw this piece of paper on my layout. This is where the toggle switch is going to go. When you flip it up, LED 1 and 4 are going to be green. When you flip it down, then LEDs 1 and 3 will be green. This tells you the direction that these things are going to go. Again, when you flip this up, LED 2 and 4 will be green. When you flip it down, 3 and 2 are green. So effectively, if you're flipping these switches in the outer directions, then it's the outer paths that are being followed. When you flip in the inward directions, then it's the crossway paths that are being followed. Right, so this diagram really helped. Let me move the cursor out. Feel free to take a snapshot or a screen dump of this if you wish to do it. I just did it in PowerPoint, so it's not all that hard. You just have to drill a hole right here. Now, let's go to the to what it looks like under the switch panel. Okay, here's what it looks like. It's messy, but it's okay. Here are the latching relays. And once we go through the parts list, you'll see what it looks like. And I did all of the solder joints of all the little cables. And then I used this, this sort of wiring strip that has screws. And this is how I could connect to, because each one of these goes to two LEDs. This one goes to LED 1 and 2, red and green, and this goes to 1 and 2, green and red, right? So, and then on this side, you just connect these things, and you can see the 100 ohm resistors, and this goes to the diodes that we talked about. That little silver strip is telling you that the current's going to go in this direction, potentially the other. I'm not good at electronics, but it keeps the current only to go in one direction. And I did this for both, and I just glued it all on or screwed it all on a piece of block. And you can see LED 1, 2, 3, and 4. Right? This is how I kept track of things in a very clean, best way that I could. And I give it a lot of distance. I'm not trying to compress this because, there's some people who are really good at electronics, but I'm not. And if I did, I'd likely solder the wrong thing to the wrong place. And my eyesight is not that great, and these things are tiny. All right, here is a closer look at the diodes and how they connect to the double pole, double throw switches. And you can see the way that I've installed them on this board on the underside of my control panel. Now you can start seeing the LEDs themselves. And the next diagram, this is a closer up look, and you can solder joints are messy, and I keep everything pretty far apart because I need
to not cause shorts. And it's just a bit of a mess. Here is a look of the whole thing and how messy it is. These are all the wires that trace back all the way to the 4 LEDs that are right here on my switch panel, my control panel, sorry. So here is the double pole, the slip switch, and where I'm going to be going, choosing which direction. Here are the 2 switch motors. And the next video will talk about how to connect these switch motors to the toggle switches that we have on the control panel. All right, let's go to the parts list.
I have a list right here. What you need is thin solder. Invest in a good soldering iron, some good flux, and a magnifying glass. The kind that I use is this. It fits over your head, and because these little peg posts and all this thin solder is very small, and I've got older eyes, so it's a little bit tough without something like this to do all of this soldering. All right, you need thin wire. You need a double pole, double throw toggle switch. They look like this, and they have, and as you can tell, I can, when I come up here and I let it go, it comes back to the center position, right? That's why it's momentary. And it's double pole, double throw because it has 2 rows of 3. The center row is usually the power rows, the way that I hook things up, and then the outer ones are going to allow the current and the latching relays to function in the way that lights the lights properly. On this side will be 12 volt DC for the LEDs. On the other side, because the switch machine I use are 18 volts AC, 16 to 18 volts AC. So the AC power will be handled on this side, the DC will be on that side. That's why double pole, double throw. And this is what you're going to need for the LEDs. There's little rubber thingies that can go above these things that I really like as well. Makes it very practical. All right. The next thing that is necessary is a red-green LED. They look like this, and if you look very closely, on one side there's an angle to one of these posts, and on the other side it's square. And what I do is I take the middle post here and I just bend it out, right? And that will go to my 12 volts. If the current goes through that side, then it's red, and if it goes through the other side, then it's green, right? And you can line things up by whether it's a square edge right there, or if it's an angled edge on the other side. That tells you which side is green. The other thing that I actually like using is these little rubber grommets that are kind of hard to show what they look like, and they have these feathers on the inside. What happens, and they have this little lip right there on the outer side. So I drill a hole and then I drop this into the hole, and then in the control panel, and when I come through this through here to punch it forward, what it does is it feathers out these little winglets and locks it in place, and it's a nice nicely surrounds the LED. So yeah, and I use 5mm LEDs because they have more light, but there's 3 and there's others that you can use. Just want a red-green LED. The next thing that's necessary is this latching relay. Now, this is kind of an interesting thing. I have no idea how the box functions inside of here. It has these 2 rows, 3 and 2, and 3 and 2, and I just hook them up according to the way that I showed you on that diagram. Now, this piece of equipment is the expensive part in the whole thing. You can probably make the whole thing for about $40, $50, because each one of these is about $20 to $25. Everything else is pretty inexpensive. Now, I bought a bunch of these all at once. Since then, I have been told by someone that he had done a search and he had found latching relays for much cheaper, for $2 or $3. So if you can find latching relays and you understand how they function and replace in your diagram what I've shown, you'll be just fine. And it's a much cheaper way to go than buying these $25 to $26 latching relays. And yeah, they're very nice. They work very beautifully, no problem. The next thing is a wire strip. It's these things. They come with these little screws that go inside of all of these. And as you saw, I had 2 of these that were surrounding the latching relay. So you can find these at any hardware store. It's pretty common. And you can find some 20, some 10, some, there's all sorts of numbers of these things. Almost there. You need resistors. They come in these packs. The colors on the vans here tell you what the resistance is. This one is 47 ohm. It says right at the top there. You just need to buy the 100 ohm version. And 1 pack of these will do the trick for this little layout. And then the last thing down this list is the diodes. And as I mentioned, they come in a pack like this, and what a diode does is it allows the current to go on only one direction. This is an NTE 588 diodes. And what they have, if you look inside, is they have a little gray band on one side, and it's completely black on the other. That means the current is going to go in that direction, right? So, and if you just want to test it, you can just put an amp meter on either side and see which way the current flows, right? And you'll know how to install it. Yeah, so the $40 to $50 for what I've shown. The most expensive part is the latching relay. Once you get that done, once you buy one of these and install it, you're done, right? You can take that and install it in any layout that has a latching relay. All right, this was the last part of installing the LEDs for this slip switch. The next video will be how to attach the toggle switches, these guys, to on this side, to the switch machines, the 2 switch machines that are controlling the slip switch. Enjoy, have fun, try it out, see what happens.